How's it going, guys? In this video we're going to answer the question, can any given element's solid phase float on its own liquid phase? Now, as I'm sure you can guess, answering this question is going to have to do with phase diagrams. So here's the phase diagram that we did in the last video, and essentially what we're looking at specifically is this line right here between the solid and the liquid phases. Now, if that line is a positive slope, as it is in this phase diagram, as it is in almost every element, it essentially means that the solid phase should not be able to float on the liquid phase because it should be more dense. And then if the opposite is true, like it is with water, there's going to be a negative phase. There's going to be a negative slope, and that would determine that the liquid phase would be more dense than the solid phase on average, and that would make it possible for it to float. So what I try to do here is make a phase diagram to kind of just show this trend with an adjustable slope here. So like I said, with most elements you're going to have a positive slope, and here's what this positive slope basically means. If you have a positive slope when the element is in its solid phase, that is going to be the more dense phase, and an increase in pressure converts liquid to solid, and the melting point increases as a result. Now, on the other hand, if you have a negative slope on that line, it's pretty exaggerated, a negative slope like you have with water, you're going to have the liquid being more dense in terms of the two phases, so an increase in pressure converts solid to liquid and melting point decreases. So essentially what that means is this whole question boils down to basically whether or not this slope is negative or positive. Now, if you can't get your hands on a phase diagram of any given element that you're trying to figure out the slope of, or whether or not it will float, the next best thing would be to try to just gather information of certain points, whether or not it's in a certain state of matter at a certain pressure and then a certain temperature, and then you can basically use that to deduce the curve. So hopefully you won't have to do it that way, but yeah, hopefully this is just kind of gives someone a quick overview of how to answer this type of question. And it basically, if it's water, then obviously you know that solid water, when water freezes, it expands. So you know that by definition it would be less dense because it's filling more space with the same number of moles. And then anything that is like water, or is a lot of solutions are probably going to be that way too, that are mostly water. So yeah, that's essentially how you can take down this question. So hopefully this helps someone.